Thanks. Well, I'm very pleased this week to introduce Johanna Wagstaffe. So Johanna is probably familiar to many of us who've listened to the radio in particular, because she's the local CBC meteorologist and seismologist and science reporter. So we've probably heard her discussing the weather, but also earthquakes, which she said was just a topic on the radio, and also covering other science topics. So Johanna's background is she did a geophysics degree at Western University. She's been with the CBC, I think, since about 2007. Did I get that right?
Yeah.
And during the recent heat dome, which of course we all know about, unless anybody's just arrived in British Columbia, she was the kind of go-to person on the media. So it seemed like every time you switched on the TV or the radio, there was Johanna talking about the heat dome. And the reason for that is because she's extremely articulate as well as qualified to talk about it. So I thought there's nobody better to try to get to describe what's been going on to us than Johanna. So we managed to catch her today, and she's literally just finished discussing the weather on CBC radio. So it's great that she's managed to join us today, and I look forward to her talk. It's all yours, Johanna.
Thank you very much. And yeah, thanks for having me today. So many distinguished speakers and guests. It's a pleasure to be coming to all of you from my home. I'm still broadcasting from my home studio. So yes, I was just on the radio, but I have all the equipment here to be going live. And this is basically from my backyard where I went live through the summer for what seemed like 2 months on end, sort of 10 hours a day of live TV, but what an event that was. So I'm looking forward to laying out a little bit about the background when it comes to the meteorology that led to this event. I know we've gone into greater detail though on with a past speaker, but I also wanted to move forward and tell you a little bit about the trickle down effects that we continue to see because of that heat dome to this day, and some of those larger scale implications and the connections to climate change. But I want to take you back, first of all, to the end of June, when myself as a meteorologist first started to see the patterns in the long range models. We can very accurately see out about 3 days with our current weather models. Or high resolution weather models are pretty accurate for 3 days. Some hot tips if you're looking at your weather apps. But about 10 to 15 days in the future, we can see trends and we can see systems moving in, and we can see the confidence levels. So it was about 2 weeks before the heat dome really settled into place that meteorologists right across the Pacific Northwest first saw the signature and first saw the potential for the kinds of temperatures that we ended up seeing. But these projected temperatures were so far above seasonal, so far above anything that we had ever seen. It was not only hard to put into context, but hard to believe that it was true. And meteorologists, I know this happens across industry, but meteorologists, depending on, some of us work for media, the industry, government, and often when we get these big, widespread impact weather events, it's about sharing information, and I've never seen that more than during the heat dome. All the meteorologists, whether we were at competing stations, Environment Canada, the Weather Network, meteorologists across the US, we were all sharing information, sharing our analysis, and sharing our thoughts to try and convey this unprecedented event before it happened. And I went back through my graphics. And funny enough, I had saved a few of these events before they laid out. And I remember, I've got one on the screen here. It was already a hot June. We had already seen temperatures well above seasonal. We had seen some record-breaking temperatures. And that's sort of this heat dome 1 down in the corner. Just the week before, we had already dealt with record-breaking temperatures. And then heat dome number 2 moved in. So this was just a few days before the heat dome really took hold. And this is sort of what our models were showing you. I'll just play that a couple of times. That red, those are the 40-degree temperatures. This is higher up in the atmosphere, but in the end, it did a really good job of showing you what was happening on the ground. And this is sort of what meteorologists saw right across the country, and why we ended up sort of realizing that this was going to be a major event. So when those temperatures did play out as they did, it was, the models did a good job, I'll say. A couple weeks out, we had never seen anything like this. We had never seen anything so high up in the atmosphere, so widespread, and an event that stuck around for so long. You're looking here at the heat warnings just across everyone in red. And actually, I'll take you through the forecast. This was just one of the days of the heat dome that I managed to save the weathercast that I did that evening. So you can see all of those reds. That's the warnings that extend across the prairies. Just a snapshot of the kinds of forecasts and temperatures we were seeing through that heat dome. And it really was widespread, east of the Rockies, well up into the north, and well down to Northern California. And I think what really solidified this event was how high up in the atmosphere this was. As many of you probably know, this started as a wave out in the Eastern Pacific. It was sort of a series of thunderstorms in Eastern China that first amplified that jet stream over in the Western Pacific. And then once we saw that wave get closer and closer and attenuate more and more, that's when we sort of realized that the models were accurate in what they were showing us when it comes to temperatures. And then that wave parked itself over the Pacific Northwest. And we talk about this term heat dome, and it really is this dome of hot air. High pressure, you get sinking air, and it ends up basically cooking the temperatures and the air closest to the ground. And because we were seeing heat so high up in the atmosphere at altitudes, we'd never seen these kinds of numbers before. I was getting messages and tweets from airline pilots who were sending me pictures of their air temperature gauges out on their wings that were 13, 14, 15 degrees at cruising altitude, up above 15,000 feet. Just incredible stuff that ended up melting the tops of our mountains in ways that we'd never seen before. And I will talk more about that in a moment. But seeing how high that heat was in the atmosphere, so every day that heat dome stuck around, the sinking air would continue to bring down and mix down hotter air that would then be cooked at the bottom. We also had something that we do see when we get our hottest of the air masses on the South Coast, something called a thermal low. And whenever we see temperatures above 30 for the South Coast, it's likely that a thermal low is in place. So when we get a high pressure that's really strong sitting over the BC interior, we sort of get this little low pressure system forming almost to balance out that high pressure in the interior. And because we see our winds flowing from high to low, we get winds rushing through the valley, bringing the hottest and driest air from the interior towards the coast. So not only do we have that hot air mixing down from above, we had the hot air mixing from the east to the west, and then we had it cooking at surface level. Add to that the fact that this event happened in late June, which is very early in the season. We had a very high sun angle, and we had maximum daylight, we had maximum daytime hours for that cooking to happen. So all of these events came together for what was a 1 in 1,000 year event, an extremely rare event that the likelihood of it happening for any one of our lifetimes was very, very low. Just taking you through the temperatures that we did hit. These are just a few of the all-time heat records, and I know you've seen these numbers before. Temperatures that we thought we might hit with climate change in the next couple of decades. And I think the old all-time Canada highest temperature record in southern Saskatchewan, we knew it was likely going to fall with climate change. And we knew that the BC interior, including Lytton, had a shot at breaking that record. But I don't think we expected it to be smashed. I don't think we expected it to be broken this early in the season. I don't think we expected it to be broken in consecutive days. We had that all-time heat record break 3 days in a row before finally landing in the high 40s, almost 50 degrees for Lytton, as you know. So we didn't expect all of those things, and we certainly didn't expect to happen this early in the decade. We thought maybe 2030, 2040 that we would see these kinds of numbers, but this definitely happened earlier than most of us thought. right after the heat event. It took about 2 weeks, and scientists and climate scientists from a rapid attenuation group were able to use their models to figure out the connection between climate change. And as I said, this was a 1 in 1,000 year event. These scientists, using their models, figured out that this event was 150 times more likely to happen because of climate change. And forward modeling, if we continue to see warming and end up with our temperatures globally 2 degrees above 1990 levels, then this will become a 1 in 5 to 10 year event by 2050, which is just incredible to see that change in risk. It's very likely that we're going to see temperatures bump up to 2 degrees. It's also very likely that many of us will be around in the year 2050, which means it's very likely that we will see another heat dome event like this in our lifetime, or at least in our children or our grandchildren's lifetime, and maybe several more of these heat dome events. I want to talk more about the impacts, but first, sort of one of the big reasons why we are expected to see more of these heat domes really has to do with the jet stream. So the jet stream is basically the fast moving band of air in our upper atmosphere that carries weather systems all around the world. We've got a couple of jet streams, but the mid-latitude jet stream is the one that sort of brings in most of our weather. And, it's wavy. We can see systems stall out from time to time. We can even see blocking patterns as we have in the past. But what more and more climate science is doing is connecting these blocked jet streams to climate change. And as the north warms at least twice the rate as the mid-latitude locations, the temperature difference between the north and the mid-latitudes is becoming less and less. And it's actually that temperature difference that drives the jet stream. So the greater a temperature difference you have between the north and where we live, the stronger and faster the jet stream, and the more likely to see systems move through. But because that temperature difference that gap is closing as the north warms faster, the jet stream doesn't have that fuel. It ends up becoming loopier, and in the case of the heat dome, stalling out completely. Part of the problem was the rest of the jet stream was blocked across the country in an omega blocking pattern. So the jet stream couldn't carry that heat eastward for almost a week on end before we finally saw that move out. And this is something we're seeing more and more all around the world. This summer was such a microcosm for the kinds of impacts we'll see because of blocked jet streams. This same summer, we saw deadly flooding in Germany and Eastern Europe. And you remember seeing those pictures of the torrential downpours. That was a locked jet stream, but the other side of it was a low that was blocked over Europe, not being able to move anywhere. These blocked high pressure systems, that's what led to our back-to-back record wildfire seasons in British Columbia in 2017 and 2018. So we're going to see more of these blocking patterns, and that means to either more days of intense rain. We're likely to see more of our rainfall events all at once rather than spread out through the year. And we're also likely to see more of these blocked heat domes, leading to not only deadly heat waves, but also to the wildfire seasons that we're seeing more and more of. Here's just a snapshot of sort of the peak of the heat dome. This is a look at temperature anomalies. So sort of above just make sure I get this right, above the 2000 and I think sort of turn of the century to 2017 averages. So you can just see how much above normal the Pacific Northwest was and how widespread this event really was. The BC Chief Coroner has attributed at least 590 deaths to that heat dome. And actually just getting a briefing from Environment Canada earlier this morning, and we had one of our health scientists on the call, and that number might be closer to 740. 740 people dying across British Columbia because of that heat wave. Most people in their homes with lack of air conditioning. Also, these new numbers coming out of the meeting this morning, 62 stations broke all-time temperature records across British Columbia. And again, just passing on this new information as meteorologists discuss this event, it looks like the biggest concern as we head into the fall season And there are a lot of trickle-down effects, which I want to talk to you about. But for meteorologists, it's the burn scars from the almost record number of hectares burnt this year because of our wildfires, fueled by this heat dome. And so what we're worried about with these kinds of rain events that we're seeing with those burn scars is runoff and eventual debris flow. So that's our big concern as we head into fall. Again, yet another trickle-down effect from the kind of heat that we saw this summer. A couple of graphs I want to share with you. Just a few weeks ago, I was part of the Union of BC Municipalities. So basically all of the governments on different levels from local to provincial kind of got together in a special heat dome panel to discuss how we could prepare for more events like this and sort of what went right and definitely what went wrong when it came to that heat dome and all the events and deaths that were connected to it. You're looking at a snapshot of June 30th, the land surface temperature with one of our high resolution models that was run for this event. And obviously the darker the reds, the hotter the temperatures. And it's really easy and interesting to pick out some trends. We can see in through East Van, parts of Surrey, mainly places, as I'll show you in a minute, where we have a lot of concrete buildings and little trees. This is where we saw some of the hottest temperatures. And this also corresponds to where we have information that the inside of people's homes, remained up around 35, 40 degrees for several days on end. Fortunately, the title didn't transfer on this one. I think this is the density of concrete buildings. And then this is also canopy cover. So you can really see the lighter greens lining up to the places where we also have mainly concrete structures. And one of the big takeaways from the meeting was that, we thought that these trends were likely there, but after looking through the numbers, it was our most at risk and vulnerable that died during that heat dome. And even though we opened up cooling centers, we had extra staff on all levels. We still had people waiting on the line to get through to 911. Most people who died were living alone and again, living in these concrete buildings. One of the big takeaways from this conversation, it really was what will likely be the first of many conversations when it comes to trying to plan for a future where we will see more of these heat domes. What's the solution? Other than getting air conditioning or some kind of a heat pump into every concrete building. That's obviously the most obvious and concrete solution, but that is going to take a lot of time and a lot of money. So already I know officials have reached out to other countries around the world, Mediterranean countries, parts of the US that just generally see temperatures that are a lot hotter than ours traditionally are. And it was interesting hearing their response and their surprise that we don't have air conditioning because that's just not our old seasonal. But I think things like tree canopy, awnings for windows, trying to block that heat from actually getting to the windows with shutters and things like that can really make a big difference when it's modeled. So I was pleased to see the start of the conversation at least happening when it comes to solutions, because it will happen again. And just talking a little bit about those trickle down effects, and I'm sure some of you, maybe after this we can share some more impacts that maybe we all haven't even thought of. The deaths obviously is the biggest one. It was just unprecedented, highest connected to heat domes in Canada. I thought the Montreal heat wave a couple of years ago was going to be one that stood for a long time, but 740 deaths connected to a heat wave is extremely significant. You're seeing a picture of the ocean on the top right. And we are getting new studies showing us that the loss to marine life was also exceptional. On all scales of life, some early reports sort of indicating that we may have seen deaths connected to the heat dome in our marine ecosystems upwards of 1 billion. So we're not even sure exactly what that means for our ecosystems in the ocean. We also know we saw massive suffering in our trees and the sort of flora and fauna across the South Coast. I know we all probably have a tree in our own neighborhood that's not looking too good. That's something that scientists are also looking at right now, trying to figure out that connection. And it was such a drought summer, even though we actually had, I think it was the 5th rainiest September ever on record for Metro Vancouver. We're not nearly close to making up for that summer deficit in the soil. We still need a solid few soggy months to be able to make up for that. So we're going to see that trickle down effect for quite some time in our trees. And going back to the burn scars and the runoff and the debris flow, things that we're worried about for the fall. Another thing we're worried about are these big fall windstorms. And especially as we head into winter, we get more of these Pacific lows moving in. Our trees are very weak and vulnerable right now because of how stressed they were. And maybe some of you noticed how early the leaves started to change, all because of that stress. So we get one big wind event and our trees are very vulnerable right now. And then, you know, it's the little stories that you don't even think about. You can see the pumpkin on the bottom right. We just did this local story yesterday. Pumpkin patches are noticing that they've had strange fungus and rot. They're not sure exactly where it came from, but they haven't seen it in previous years. And a lot of local farmers saying that they're just seeing things with their crops that they haven't seen before, again, because of that exceptional heat. So I think it's going to take some time for us to fully realize what that heat dome has done. And I think we really have to ramp up how to prepare for that next one. There's just sort of end on a bit of a positive note. We are heading into a La Nina year, which, as some of you may know, generally for us means a cooler and more wintry or higher chance of snowfall at lower elevation for British Columbia. So skiers and snowboarders rejoicing, but we could also really use that moisture on all levels in our soil. We know already, on average, British Columbia has warmed 1 degree since the turn of the century levels. And we know with our current emissions, we're likely to warm at least another full degree by 2050. And, you know, I sort of had this realization the other day. It looks like, I haven't officially shared it yet, but I'm just having some meetings earlier today that CBC might send me to. It looks like they'll send me to Glasgow for the climate change conference, which, you know, I'm thrilled to be able to report from the ground, but sort of thinking about the stories that I wanted to tell on the ground and really using the heat dome as a snapshot of what our future might look like here in British Columbia. I realized that, you know, many of us will be alive in 2050, and you know, having a 2-year-old son, he'll definitely still be alive for the middle of the century. So the actions that we take now mainly need to be adaptation for the next 30 to 50 years. You know, the CO2 that we have pumped into the atmosphere will continue to warm our atmosphere until the turn of the century. But the actions that we take now will be able to change that 2050 to 2100 range. And I think we need to prepare for more of these heat domes, but we can stop that number going from a 5 to 10 year event to an every year event, which might happen if that 2 degree number becomes 4 degrees. So for myself, just in conclusion, I think, you know, the heat dome was tragic, but a little bit of an insight into the newsroom and sort of this two-way conversation that we have now with our audiences. I've never seen a tipping point like I'm seeing now. And, you know, I wish that we didn't have to have this galvanizing moment. You know, I thought that moment for us in British Columbia was the back-to-back wildfire seasons in 2017 and 2018, the smoke that we saw last fall. But this heat dome, I think, had more people talking about climate change and about climate change action than ever before. We've had more calls into the newsroom and more emails asking us to make that climate change connection than we have from climate deniers. So that's where I end up being hopeful to see that turn in our audience and to see that turn amongst many British Columbians. And, you know, hopefully we can continue to tell the stories from around the world so that we don't have to live it to create galvanizing moments. We can share those from around the world. So looking forward to chatting more with you. I think I've left lots of time for questions and, you know, and maybe your own observations when it comes to what the heat dome has done to this province. Thank you very much.